I just leave them on the floor there, so. I'll just do my spiel and then you come up here. So. Is there anyone out here? So, is there anyone out here left, or? No. Oh, okay, fine. So we'll kick. Oh, okay, all right, fine. Yeah, they'll come in. So. Okay, we'll kick off now. It's just about. Try to stay away from the cameras in that case, yeah. So yeah, welcome to the fourth Robotics Network event organized by us and hosted by Shoosmiths, one of our sponsors. Other sponsors also include Onshape today, who will be talking soon, and Gillespie Manners, just outside, recruitment consultants if you need a job, or have a job indeed. Firstly, there's no fire drills organized tonight, so if the fire alarm should go off, you should make your way out. Toilets are located just outside the lifts to the right. And as I said, yeah, it's a live streamed event, so, and during the break, the live stream will continue until the last presentation, so just remember that, yeah. Sorry. So I'll keep it really brief here with my background. I'm a publisher of a free-to-download market research report. So if you have looking into any of the robotics markets, in particular mobile robotics, you can download a free report from our website. So why did we start these events? In 2020, we found out that the UK robotics scene was very limited, and we wanted to do something about kind of helping this, and we started these events. And obviously we started with webinars first, and in 2022 finally, thanks to Shoosmiths as well, we started holding these in-person events, and this is the fourth time that we're gathering an audience here. It seems to work. The audience have grown since we started out. So yeah. On that note as well, if you want to get involved and do any presentation to the audience here, please contact me either after the event or just in the breaks here. We have 4 exciting events planned for 2023, the first one today and the second one in May, and quarterly after that as well. Yeah, so with that in mind, I'm going to introduce you to Anna-Sofia from Onshape to do the more exciting stuff on this presentations. Thanks.
Thank you, John.
So let's go into your...
Yeah.
There we go, and we'll start the video.
Thank you.
At Ocado, we never underestimate the value of streamlined collaboration. We need our tools to help people get work done, and we have development centers all over the world, and we span time zones all over. The 600 series bot is the world's lightest and most energy efficient grocery fulfillment bot. We've designed it in Onshape using the latest in additive manufacturing and topology optimization techniques. And with it, we're going to help our clients get their operations up faster, more cost effectively, and in all different kinds of flexible buildings. So we used Onshape at first in our prototyping activities, but as it's become visible to more people in the organisation, it has started growing organically, and it's now used enthusiastically by quite a few teams at Ocado. We make big, complex ecosystems of products, and that means there's a huge amount of collaboration between teams that needs to happen. Being able to share the real engineering information directly is phenomenally powerful compared to sending a screenshot or writing a report. You just get the product data in the person's hands that needs it. We think of Onshape like the Google Docs of CAD because we can share instantly. I can get the engineering data in front of stakeholders, senior management, procurement guys at the click of a button, and I don't need to worry whether they've got any specific tooling installed on their machines. In our group, we're spinning a new generation of our robot every 3 weeks. So it's a pure agile approach to hardware development. And it looks an awful lot like Onshape because we get new releases from Onshape every 3 weeks and we get to exploit those features straight away with no updates needed on our side. We've brought a lot of software development methodology into how our departments run, and some of those techniques are made significantly easier by Onshape, like the CAD equivalent of pair programming, which we use extensively in our group. If you have a connected environment where 2 people can edit the same document and be on a call at the same time, then you can collaborate internationally on complex designs. With the API and feature script capabilities in Onshape, we can extend it to match the processes and special tooling that we need to do our jobs. So we love the core product, and we love even more that we can extend it and make it just what we need for the job.
Thank you.
Press down.
Thank you. Should I go to the second slide already?
Yeah.
The second one.
Press down. Got it, yeah.
There you go. Thank you very much, Tom. And thank you, everyone, for having me here tonight. My name is Anna Sophia Barrows, and I am the sales manager for Onshape, and I run the EMEA region. And what you've just seen is Ocado, one of our customers. And I have to say, the company values that they have is almost a perfect match with the reasons why we developed Onshape. So I promise that today I won't be taking much of your time, but I wanted to give you a quick overview into why we created Onshape and the reasons why companies like Ocado chose Onshape as the CAD and PDM solution. And for that, I'm going to be sharing some stats with you. First of all, Onshape was created by the same creators of SolidWorks. And thanks to that, we can say that today Onshape is the #1 fastest growing CAD system in the market. We are growing 7 times the average rate of the CAD market, and we have already over 2 million users. So again, why are companies switching to Onshape? 3D CAD has been in the market for over 30 years, so longer than I've been alive, and already telling you my age in here, right? So why are established companies looking into Onshape? One of the reasons is because today Onshape is the only cloud-native solution that has both CAD and PDM together as one, all in the cloud. But the companies are also looking into Onshape because they're facing some challenges. Now, what are these challenges? For instance, the high total cost of ownership. So they buy the CAD software, they also have to think about buying a PDM if they want to manage the data. Then they have to think about the costs of the workstations, the servers, and so on. And they want to reduce the costs. So reducing the costs is one of the reasons that they're looking into Onshape. Another reason is because they cannot find the data in a timely fashion. We actually did a research, and we found out that 80% of the time of the engineers are spent looking for data. And security. All the companies want to make sure that the intellectual property is safe. And you cannot really guarantee that when you send emails back and forth between different people. And with Onshape, we try to guarantee that. But also the system of check-in and check-out that you have with PDM and PLM systems, which has a domino effect into the collaboration because you cannot have simultaneous collaboration. And if you add on top of that, crashes, data loss. So for all of these different reasons, people are looking into Onshape. And I bet that if you use a CAD software today, and this is a bold statement for me to say, you have come across at least one of these challenges, right? So the reasons why people look into Onshape, where I said one, it is a cloud-native solution, right? So this means that you can use Onshape in any type of device. It doesn't matter if you have a MacBook, a Linux, a Chromebook, a Windows, if you're using your mobile phone, if you're using your tablet, you can use Onshape from any device and anywhere. You have simultaneous collaboration. You can have live collaboration. So you can be working the same design at the same time. But you can also have on-demand analytics. So you can see how many hours your engineers are spending on a given project and how you can actually allocate your resources. Who made it, what changes, and when they made those changes. And it also has an intuitive user interface. This means that even people that have no CAD background can use Onshape in a very easy way. And it is very secure. Why? Because everything is in the cloud. So you're not sending emails back and forth, and it's secured by the Onshape walls. And another big statement for me, it eliminates crashes. So the user interface does not face crashes. And the reason why we say this is because with Onshape, you're using servers. So this means if one server goes down, the other one takes over. So the user experience is as if never happened a crash. But let's say that for some reason, something crashes. Your laptop goes on fire. No worries. You can just go to another device, and you can keep on using Onshape without losing the data, because Onshape saves everything automatically. So again, you never lose the data. And as you've seen in the Ocado video, we update the software every 3 weeks, and there's nothing else that the user needs to do because it's all done automatically. And it's not just Ocado saying that they like Onshape. We have a lot of different companies saying that they love Onshape. And I was allowed to say that Covariant, who's also in the house over there, is also using Onshape. So you can hear directly from our end users what is the experience of using Onshape. And I promised I wasn't going to take much of your time. That's it for me today. If you want to learn more about Onshape, you can go to onshape.com or email me at abarrows@ptc. I have 7 t-shirts that I can give, so if you really want to talk to me over there, but we also have some flyers around. So thank you very much for your time, and have a good day. Thank you, Tom. Thank you.
The thing as well. Does anyone have any questions for Anosphere, by the way? Otherwise, we'll just kick off with the next presentation, which is from Crover, I believe. We'll just have to fix this to him first of all, yeah? So, you got that. We said it could go like this, yeah? And your presentation. By the way, if you want to talk to any of the presenters, you can connect with them either where they're showing as well, or after the presentations as well. So, here we go. All yours.
Thank you. At Crover, we are known for having developed the world's first device able to move inside bulk solids and powders, which is any assembly of solid particles like sand and chemical powders. And we have set ourselves on the mission to help grain storage operators maintain the quality of their stock. Does this work?
You should press down.
The reason why we decided to start by addressing the problem of grain storage is that it still represents today the single phase with the highest post-harvest losses before consumption. So we built a grain storage management system around what we call the Crover robot that mainly provides 3 features. One, it measures moisture and temperatures, which are the main indicators of grain quality as it moves through the grain, the bulk of the grain, building a 3D map of conditions and pinpointing the location of problematic areas. 2, it helps aerate the grain, which helps maintain the quality of the stock. And 3, it keeps grain storage operators out of the grain bulk because they no longer need to walk on these dangerous substrates. So now, at the moment, we are launching the first commercial version of our grain storage management system, to which we added a second robot, a big mothership that can move much faster on big hills and deploy our probe that goes down into the bulk to take measurements and samples at depth. Along with the launch of our product, we'll also... Okay, I'll let the video talk. So this is just a little quick demo of the system in operation in a grain storage facility. We've got a little trolley add-on as well to make it easier to carry it. And then the operator can kind of use a remote control to move the robot. So we are kind of slowly releasing more and more automation features as well. And then all the data gets sent to our cloud so that they can visualize the condition of their stock remotely and get condition alerts if there's any problem with the bulk. Now, if people, whether grain storage operators or port operators or grain managers, are interested in buying our system, we offer two options. One is effectively a hardware as a service. They can purchase a subscription that includes lease of the hardware, all the data side of things, and web platform as well as remote support. Classical hardware purchase with the option to buy a subscription for the service additionally. But there are a lot of other potential applications that we see of our system in the future, the most immediate one being the management of other types of granular bulks that are stored in similar ways to grain in the likes of ports. We are based in Edinburgh. We recently moved to the newly built National Robotarium. We've got a really cool facility there where we set up also our own product testing and self-certification site. And I started Crover off the back of my PhD at the University of Edinburgh, where we discovered what we like to call the Crover effect. So in simple terms, we discovered that there is a coupling between rotational and translation motion in granular media, which is what propels our probe underground. So if anyone is interested to learn more, we've got our little stand there with our two main robots, and I'll be happy to take any questions. Thank you.
Ahead of time, which is what I like, really. So, any questions for Crover from the audience?
So you find something in the grain. What options do the operators have to do something about it?
So at the moment, the main intervention options are aerating the grain, so pushing cold air through it, either if they have like kind of a floor system that can push it directly, or some farmers have like kind of these big aeration columns that you can put it in the spot that you want. But what we really want to get to in the future is topical intervention, so addressing the problem locally where we find it. Because right now the way they do it is very inefficient, and the energy cost of aerating the grain is one of the biggest costs of it, if not the biggest.
Right, we have another question down here. Please, could you just try to repeat the question for the live stream audience as well? So.
I've heard, I don't know much about grain storage, but I've heard that it's a very dangerous environment, particularly susceptible to flammability.
Yep.
I was just curious if there's challenges from your point of view in convincing grain storage owners of being able to maintain that risk, manage that risk.
Yeah, so helping people manage a risk is one of the main selling points that we've seen, especially from large operators or ports. Like the more serious ones, they don't send anyone on the bulk because it's a really dangerous thing to do. If you sink in, there's usually nothing that can save you. And because they can't do that in a lot of their storage units, they have absolutely no view of what's going on, if not at most kind of taking a measurement at the very front of a very large bulk, so they can't even see what's at the back at the moment. Which is one of the reasons why a lot of these companies have been reaching out to us. The flammability aspect, that's another thing that we've been asked to help out with. So far, we've been focused on working with kind of non-explosive atmospheres, but we've been working on a kind of ATEX or UKEX version to deal with biomass and more explosive bulks. Yeah.
Thanks for that. So I think that's all questions we have time for with Crover. You can welcome to talk to Lorenzo later, if I can get your mic as well. Thank you. And next up is Arnaud to talk a bit about his experience at DJI. There we go. So this one.
Just push it here like this.
Yeah.
Good idea. Okay. All right.
If you get this one as well for this audience here.
All right.
Go down. I think you have to use this one. I can't really see.
Just put me on the page and I'll.
Which one?
No, just do it like. I mean, it's not
like this. Or?
I'll just do it like this.
Okay, fine.
I'll just scroll down.
Thanks.
All right. Okay, 5 minutes to give you the answer to something that is still a big mystery in this industry. And, I got some inside look, so it's a bit puzzling, but hopefully I'll be clarifying for you. So my name is Arnaud Thiercelin. I'm a tech executive I worked on many different things, but if you heard about me, that's probably because of the time I spent at DJI, where I ultimately ended up running the developer technology department from Palo Alto in California. So I'm not going to tease you much. I'm just going to give you the answer right away. The real difference over there is a question of mindset. People at DJI think and act differently than anything else I've ever seen elsewhere. And I've been outside. The understanding what it really means is where the difficulty really lies, okay? And rather than giving you a bunch of abstract concept, what I want to do is walk you through how I got to understand that I had this mindset, how I was enabled to take it to the next level, and then giving you a little bit of an understanding of the kind of results you get when you are having this mindset. So this is me. I joined DJI in 2016 as an iOS engineer on the mobile SDK team. Back then, we were working on the third version of it, which was the first big one that came out, allowed people to do stuff with it. And as you would expect, I was put on tasks that were small, different kinds of bug fixing and functionalities. But to my own surprise, very quickly I was thrown with the biggest legend in the team to work on building the next big iteration of the architecture, which is called Mobile SDK 4.0. This was a very big deal because what we did there is we abstracted completely the hardware from our developers so that in one application could connect to any kind of DJI products without them ever having to worry about this, right? So a very big milestone, very big chunk of work. This became a mainstream project. The entire team was working on it. And I was thrown to the next challenge. My boss came to me and he said, I want to build an SDK where our developers can create a DJI Go-like application in 30 seconds. Oh, and you have a couple months to present this because I'm showcasing this on stage. And with this at hand, I went working and figuring out how to build what is currently known the UX SDK, which was the UI library. Escalating. This became a mainstream project as well, and the rest of the team went on with it, and I was thrown into another challenge. And this time it was about, I had 2 months to build on my own an autonomous solution to inspect wind turbines with drones. Now, I'm a pretty decent engineer, but I had little to no background in robotics, so this one really kicked my ass. But it was an incredible experience, and this is the kind of opportunity that a place like DJI creates for you. The 2 months turned out to be 18 months in total. The solo operation ended up being the work of multiple people, and testing this solution pretty much everywhere you can think of in the US, including China. Ultimately, we knew that we were not going to be presenting this as a final product because we were building a platform. And so as such, we were more interested in inspiring people and building technologies on top of our platform, and we're interested in augmenting that platform. So we presented this at Airworks, our annual enterprise conference, and then we really showcased some of the products that came out of it, 2 of which are the Manifold 2, which was this onboard computer that was originally destined to become an educational platform and became a core enterprise and developer technology to allow people to build advanced AI applications on the vehicle in their own hardware. Another piece of tech that we came up with is what is called the SDK Interconnect that allows you to have software on the payload, on board, and on the ground working seamlessly, discovering themselves dynamically, and then being able to adapt themselves with their presence or their absence. And the third parties got super inspired as well. Now, this is one of the less known applications, but one of my favorite. This is a gamma ray detector. One of the tube has a crystal, a very special crystal, that reacts to gamma radiation that could be leaking out of nuclear cores. So you fly these things next to the concrete isolation core of a nuclear power plant, and you know whether or not it's leaking or it's still containing as it should. Now, I know it's super short, but what I'm really trying to point out in here is that DJI is winning because it's a place of people who believe that if you bring people who have skill and courage, which I affectionately call crazy, and you give them the opportunity to take this as far as they can, they will create crazy products. And I have been on both sides of this industry, so I can tell you firsthand that there's countless robotics companies who are on the complete opposite spectrum of this. For them, everything is too difficult. They don't even look at a problem and they've already given up on it. DJI is a place where nothing is impossible. Everything is worth going after. And I'm far from being the only example. I just happen to be somewhat visible, and that's why you hear about me, but there's so many of my colleagues who even took things further. Now, I've taken this mentality and pitched it in my positions afterwards, but I've recently decided to use my visibility, my public stance to talk about this more publicly. So if you're interested, you can follow me on LinkedIn because this is the place I talk about this. And if you're into crazy project, come and talk to me about how we can solve the water scarcity problem of humanity using an army of mobile robots, because that's what I'm working on right now. All right, any questions?
Any questions for Arnaud? Yep.
Open-ended questions, but I would love to hear more about this army of AMRs and problem solving.
Sorry, okay,
Yeah.
come get me after.
Sorry, can you just repeat the question as well, if that was a question?
Open-ended question.
Yeah, but for the live stream audience, just repeat it.
You want to talk more about my water project? Yeah. Any other questions? All right, thank you.
Okay, so yeah, just catch Arnaud afterwards and you can hear all about it, I'm sure. Yeah, so just that one as well. Thank you. Thank you, Arnaud. So next up is Wootzano. So this one goes on there, I think, something like that. And here you go, you're just press down, yeah? That's for this audience. Speak closer. Got it there, yeah? Oh, okay, 5 minutes.
Hello everyone. Hi, I hope I'm audible. Yeah, I'm Ravi, robotics lead at Wootzano. So we make highly dexterous robots for fresh produce industry, which is post-harvest. So let me just walk you through the basic supply chain of fresh produce. So which is primarily has 4 stages, which is growers, packers, and logistics and retailers, where we buy all the fresh produce. So we primarily focus on packers, where we'll be packing the fresh produce, especially the grapes and vine tomatoes, which are currently handling with. So this is one of the most challenging industry where you need to delicately handle the fresh produce without bruising them. So, and with the current scenarios of labor shortage and the inflation, availability of labor itself, it's much more complicated. So, but the task itself is highly labor intense because there is no such technology which can delicately grasp the fruit without damaging it. So at Wootzano, we have developed a product which is called Avarai, which is, I can proudly say, it's one of the first commercially available product which is developed by Wootzano with our latest and patented e-skin, which has far superior abilities compared to the human skin. I'll walk you through basic idea about skin, which has mechanoreceptors. So each of us have a mechanoreceptors on our palm, which are approximately around 58, and fingertips are kind of more sensitive compared to the palm, which has 241 mechanoreceptors, whereas our e-skin is far superior. It has almost 7 billion nanowires, which act as mechanoreceptors, which can give huge amount of data, which is crazy, and it is very challenging to process such amount of data. At Wootzano, what we have done is, we have found a technique where we can process only the data which is desired and which is required. And the skin which have been developed, and you can crush the skin and it will regain its shape to its natural position and it will work as it is. So this is where the trick comes in. How did we integrate it to the robots? And how did we make use of it? So we have such certain machine learning techniques which will process the data continuously. Along with the e-skin technology, we are also integrating the machine learning techniques with computer vision. So where the computer vision will give all the details about the fresh produce. As soon as you put a bunch in front of the cameras, it will give almost all the details, including the color, shape, structure, and these will be integrated with the e-skin, and which will give us almost all the details. And the most challenging part of the fresh produce is each and every fruit is different from each other. The complexity of the shape, so the models which you have developed has, based on various amount of the data, we have trained our models using tons and tons of synthetic and actual data, which will give us accurate results so that it can be dexterously handled by a robotic arm, which will be dynamically planning the path based on each and every fruit. And it is very, very modular. It takes almost the space of the human being. Exactly to say, it's 60 cross 60 cross 80 centimeters. So that is exact space which a human being is taking. And the most important and interesting part, which I like, I work the most on it, is skin controlled grasping. So whenever you are trying to grasp, human being, when they are working for the longer hours, they might crush the fruit based on longer hours and if they are tired. But our e-skin technology, which will enable the robotic arm to handle each and every fresh produce with utmost care. So we have recently tested our product almost on 1.5 tons of fruit, I can say. So which have been amazing results. Because of the fresh produce industry is low margin industry where they want even if they are struggling to find the labor, even if we could able to pack the fruit at the same rate that humans are packing, they are happy. But we have developed the futuristic lines which are collaborative in nature, which will be working alongside with the humans. These are the completely lines where humans and robots working next to each other, and these will be providing almost 30 to 40% reduction in the labor, and the production capacity has been increased by 1.5 times. And the ease of integration, as I mentioned, these are very, very modular systems. They can easily slide in and slide out. We can break and make the lines. And the most important part of the fresh produce industry is it is very much seasonal and they don't have the demand all the time. So our lines are very, very compatible and they're very easy to maintain. And the customer acceptance is very, very huge, and we are eagerly waiting to take it across the world. And that's it about it. If you want to know more about it, you can definitely visit our website. And if you have any questions, I'm ready to take it.
Thank you, Right. We have time for one question, if there are any questions from the audience. Okay, down there. So please repeat the question as well when we hear it.
Yeah, thank you very much for the presentation. I have many questions, but I'm going to start with one.
We'll have time for one, so go for
it. You mentioned that there were a lot of data from the kind of like skin, and then you would be able to filter which type of data you're going to use. Could you please elaborate on that?
So regarding the data that they collect for the product.
Yes. So the data, the most challenging part is what amount of data we need to process and where you get the contact. The approach what we are following is, even in the human skin, how we work is, it won't send all the signals from each part of the body every time. So if you are touching something, the brain works in such a way that it will get information only from the fingertip. So what we are trying to do at Wootzano is trying to get the data where the fruit actually came in contact. So we'll be understanding the differences in the resistance. There are various parameters which are taking from the skin. So we'll be understanding all those parameters, and we have built a model such that it can intelligently tell the change. And we are processing those data to make the decisions. So that's why it is very, very quick.
Okay, excellent. Thanks a lot for that, Ravi.
Yeah.
We now have half an hour break. I will come out and hustle you in back later again, so feel free to go and help yourself to drinks and so on as well. For the live stream audience, for you at home or at work, we'll be back in half an hour. Feel free to look at all the people standing in front of the cameras. Have a great day. Right, guys, could we have, could everybody take a seat, please? So can Martin come up as well to start talking about Mo-Sys and STIQ Robotics? So you already have that one. That's for this audience. Please speak close to the, this is pressed down for the next slide. Yeah.
Down for the next slide.
Yeah.
Okay, nice pleasure to have the opportunity to present today. I'm going to talk about a new company which is called STIQ Robotics. It was formed last year. It focuses on industrial automation and drone guidance. It's part of the Mo-Sys group. So Mo-Sys is the real company and where we get the technology. Mo-Sys is a company that really operates in the film and media industry. So all the special effects on Strictly Come Dancing, how you integrate the live action spots. The spots cost almost nothing. The key thing is it's immune to interference from lighting. It can work in the dark. It is a very robust system, and as you said, it's used on the TV news. You can see that the virtual and the physical pictures match seamlessly, and if they don't, you spot it immediately. It's so that's the key thing about Star Tracker. So why we set up STIQ? Oops, wrong way. Let's go this way. Well, we think it's a setup. We can literally set it up very quickly, self-learning with our software. We've got a ROS interface. We've developed the one over there, if you can go and have a look at, is film and media version, but we're developing a lightweight, lower powered version, which was particularly optimized for the automation market. Where are we focusing? Inspection reproducibility. So when you're inspecting in vessels or equipment, you need to make sure you're looking at the same spot every time. So this accuracy of pointing is very important. I came to it from how do we actually unload liquid chemicals on an industrial plant. That's where I got the first interest in this. And you need to move the IBCs very accurately if you're going to handle toxic chemicals and not spill anything. So that's where we came from. We can operate from moving vehicles, so because you can put the star map on the vehicle, so you can know precisely where you are relative to a moving vehicle, which can be pitching and rolling. The autonomous transfer, we've got our own AMR there, which we've been testing. We've also got our own drones. We've been flying around the offices and pointing very accurately at various things around the offices. But we're actually also very keen to work with other companies with their own drones, and where we think our accuracy of guidance, pointing and robustness is going to provide benefits. Particularly, so some of the areas we're looking at is offshore wind and industrial tank inspection. Okay, how am I doing for time?
1 minute.
1 minute, okay. That's basically, right, oh, so back along the wrong way again. So that's basically what I've got to say. As I said, we developed the technology, we made 2,000 of those, it's available, it's robust. We now need to find the right industrial applications for it. So if you think you've got the right application, come and have a chat, I'd love to speak to you. Thank you very much. Any questions?
So yeah, do we have any questions for John?
How much does it cost?
How much does it cost? Well, if you want the full fat film and media with all the lens technology on, 20 to 30k. The Star Tracker Mini without the lens functionality on is going to be very much less than that. We haven't actually got exactly the price point, but again, it depends how many you want to buy. I can do a deal if you want to buy a lot.
All right, great. Thanks a lot. And if you have another question, I see that's coming up, please talk to John afterwards. He'll be around his display as well.
Come and have a look at the demo.
Yep. Sorry, can I just nick this from you? Yes, I do. And this one.
Okay, thank you very much.
All right, with that, so we're moving on to Cambridge Sensoriis. Can you fix that yourself? And I will start your... There's your microphone as well. Speak close to the microphone, please. And here we go. Press down. Okay, there we go.
Hi, good evening. Thank you for your time. I'm Steve Clark. I'm the founder of Cambridge Sensoriis. As the name implies, it's a Cambridge-based company. It's a startup, been going for about 3 years. I'm the founder. I've been working with radar systems for about 20 years or so now, largely in different automation areas. And this business is using radar systems for the drone industry. Support resilience, navigation, and awareness. What does that mean? Well, if you stick with me for a few minutes, I will endeavour to show you. If I can get the clicker to work. There we go. So why would I talk about radar in the drone industry? Well, we think radar is a perfect sensor for use on drones. It's long range. It works in all weather conditions, not affected by different lighting levels, and you can detect small objects at long range over a wide field of view. But radar's been around for a long time now, in different guises, detecting aircraft in the sky, and indeed on missile systems, on aircraft, detecting other aircraft. Technology's become cheaper and lighter, often driven by advances in chipsets and technology from the automotive industry. Radar's widely used as an ADAS, an advanced driver assistance system on cars for emergency braking. So we've taken that technology, made small versions of radar, low power, to deploy on drones. For what? Well, to detect objects that you don't want to get close to. If you're flying a mission that involves being around other buildings, or indeed where other drones may be, or other things that aren't announcing their presence, like hot air balloons or hang gliders, uninstrumented systems. If you're flying some distance away from the oversight of ground-based pilot, a radar system, such as the ones that we have designed, will allow you to detect those objects, track them, classify them, and report them to the mission computer that resides on the drone. Another use of radar is to locate the platform relative to a fixed point, or in this case, a moving point. We've developed a capability whereby a radar can collaborate with multiple other radars, and you can locate a drone in the sky. So in a situation like this, if you're approaching a vessel that's underway, you can't guarantee what the sea state is, you can't guarantee what the atmospheric conditions are like, particularly in a naval situation. Those things don't cooperate. You can locate the drone relative to the moving platform, which may be tilting and pitching, within a centimetre. We developed that technology and IP in-house, and I've got a demonstration kit in the corner, right at the back there. Very happy to show you it working. We've got 2 static radars, which will be on the deck of a ship, and we've got a moving radar, which is on a chair, which is our substitute for a drone. But we are also, incidentally, working with Sky Drones over there, who brought their drone, and we've got projects using that very same radar to support autonomous landing. Wrong way. There we go. So, but not just drones. Radar is a great localization tool and obstacle detection tool in all sorts of conditions. I started off working on machines like this for actually Komatsu dump trucks. Our radar is being considered for projects to localize those machines in areas where GPS cannot always be relied upon. It may be blocked. You may be operating underneath a crane. Localization with systems that are robust to dust and fog and rain are where you should be considering radar, we believe. Thank you. Thank you for your time. Please ask me any questions.
All right, thanks for that presentation. And again, I really love when people are on time. So you had 30 seconds to go. So do we have any questions for... So the question is, what's the field of view for the streaming audience?
Yeah, maximum field of view from a non-magnetic scan system to 120 degrees. That way. And both ways, yeah. From a flat panel, which is not moving, 120 degrees. Any other questions?
And have you combined data sets together with LiDAR and other sensors to...
and video particularly, yeah, no. It's a good idea.
Because you know that's the big problem with mining machines, for instance, is
yeah,
LiDAR and visual cameras.
Yes, and we're talking to companies who said, look, we tried using cameras, we tried using lasers, in these circumstances they just don't work. Yeah. And that's not just me saying that,
no,
our customers are saying that. Radar's a great sensor to solve that problem. Data fusion with other sensors is optimal, but it's not us. Our partners and customers will be doing the data fusion. We provide the radar sensor.
Awesome. Thanks for that. If you haven't asked, you can see there are questions as well, but please contact Steve in the break. Yeah, and with that, we're connecting to. Sorry, I need to get your microphone. You left it. Okay, hope you can fit that to yourself. And with that, we have Acuity Robotics coming up. Press down. This one as well. Sorry.
Yep. Multitasking. Great. Good evening, everyone. I'm Matthew Hopkinson from Acuity Robotics, and I've got my colleague Jason Liu. So any burning technical questions, he's the brains behind it all, the CTO. So we've got a very straightforward mission at Acuity Robotics to be the leading global provider of asset intelligence on ferrous infrastructure. And to that end, we've created and designed a couple of robots, which you can see at the back and you can play with later on. We've spun out from the University of Leeds, and they're sort of mechatronics, one of the leading sort of robotics centres, and to date we've been funded via the university and a series of grant funding, and most importantly in the last sort of 12-18 months, because we've been going just over 2 years, we've got development partnerships with BT, Unipart Rail and Glacier Energy, so we're very much engaged with use cases of how we can apply our robots, but most importantly, which we're going to come on to, is the data capture. In terms of the unique proposition, The key thing about what we do is not only have we built and created robots, but we've also created a system that captures the data, and ultimately our goal, which we're heading towards, is about predictive analytics to understand predictive maintenance on this ferrous infrastructure, because that's one of the big costs for all these companies. You know, why do you inspect something annually? Because we always have done. Well, perhaps you might need to inspect it every 6 months here and every 3 years over there. And all of you will be aware, as you see in the paper, that certain wind turbines have in different parts of the world fallen over, and that's an incredibly expensive issue. So we're hoping that the insurance industry will also be interested by what we can provide in terms of that data to demonstrate the integrity of the assets. In terms of what we're doing, there's a whole, I'm not going to go through them all, but the most important thing about what we're able to do is you can deploy what is the world's smallest untethered robot, and we've got one for internal and external inspection, and you can do that while assets are live and on. One of the big issues when we speak to the market is we have to turn off assets, we have to turn off masts. There's a cost to all of these people when they do it, and particularly with wind turbines, you're turning off a string of them. So if we can provide a solution which can provide inspection on an asset while it's still on, then that's a massive gain, and that's where we're sort of heading in that direction. The other thing which is coming out from a lot of people we speak to is removing humans from asset infrastructure, whether it's away from the railway line or the fact that you have to deploy people to hang off wind turbines. It's costly and it's also very dangerous. So any way that we can automate it with robots is absolutely key. Now, one of the key bits that we're solving here is not only just the inspection, but creating data in a structured format. It's amazing what lack of structured data there is out there in order to create this sort of predictive analytics on it, to be able to look forward. And in many cases, you have people, particularly in telecoms, who go up and down a mast and they tap it with a hammer, they listen to it and think, well, that's a 6. And then someone else might come along next week and say, well, that's an 8. So it's not fit for purpose, essentially what it is. The other thing is obviously by creating structured data, you can use APIs and other factors to build into wider systems. We've got 2 robots here that you can see. We've got Stoke, which is a small internal inspection, visual inspection robot, and then we've got Squirrel, 6-wheel drive robot. Why it's 6-wheel drive, it's taken 2 years to develop it so it doesn't fall off. And you won't be able to pull it off either, is the fact it can go over aluminium bands, bolts and everything else. And then on the far right-hand side, you can see the really important thing is the operator can see everything that the robot can see, and all of that data is being recorded into the computer to create the structured data. Now, what you can see here is ARID, which is our infrastructure dashboard. And when all the data goes through, you've got the ability to then remotely start to annotate it. And on the bottom right here, if you go up there, you'll see we've got an EMAT sensor on the front, which is looking at metal thickness. So we've got the capability to technically look at the inside of a structure from the outside. And this is sort of ultimately the most important thing about our solution is this slide here and what we're able to do with the data. In terms of the application to the market, you can see a number here, but increasingly every time we go to an event, someone comes up with a new one, like Nuclear's come out today and at the BT Festival. But I think that fundamentally telecoms and onshore wind is probably our best place to go. Finally, because we're running out of time, I'm going to leave you with this quick video which summarises everything I've said and you can see it in action.
A spin-out company from the University of Leeds, and they built the smallest untethered robots in the world that climb ferrous infrastructure. I think the key aspect about this innovation within robots is the fact they're tetherless, they're small, and they can access inaccessible places. It removes health and safety issues for humans accessing this kind of infrastructure. It creates structured data which can be used to create predictive maintenance modules and schedules. And finally, it enables you to access infrastructure in a more cost-effective and efficient manner than you can. And this is what is going to be critical as we grow infrastructure across the world, most of it which is ferrous infrastructure, along with an easy-to-understand data and insight system which will pull out reports based on what you require across thousands of assets globally at the click of a mouse.
And that's it. Thank you very much.
I'll just take the mic. Sorry, your video ran over, so we don't have any question time for that. But if you have any questions, please connect in the networking break. Yeah. With that, we're going through to BladeBug. Yeah. Cool. That one there on your. Just let me see.
Right there.
I hope so.
We'll find out.
Let's see the BladeBug. That's yours as well. Press down for next slide. And there we go. Awesome.
Cool. Hello, everybody. My name is Chris Sheslak, and I'm from BladeBug. What is BladeBug? Well, it's a robot that's designed to essentially make wind turbines operate better and help accelerate that transition to net zero. So we want to do that by maximising the amount of times that the turbine's operating. We want to do that by reducing the risk, and we want to do that by increasing the efficiency of these turbines when they're operating. And we're going to do that with our, I think it's fairly unbiased to say, pretty awesome robot, BladeBug. So why are we doing this? Well, wind turbine blades are huge. There's 1 million blades spinning around the world, and they need to be inspected, they need to be maintained, they need to be looked after in order to generate as much power they can and minimise the CO2 that's generated in other forms of power. But these turbines are getting bigger. The new generation of offshore turbines are being placed at hundreds of kilometres from the coast in ever deeper water. These places are really challenging places to work. And there's a shortage of people now doing this, but the market is set to grow tenfold between now and 2035. So there's going to be a huge challenge of getting people to do this. And there's also quite a few people willing to do this in those environments, basically dangling from ropes, doing inspection, doing the repair tasks. Coupled with that, the blades are now in excess of 115 metres each. Using the status quo of using rope access technicians, it's not really feasible. So what is BladeBug and how is it going to solve the problem? Well, BladeBug is essentially two parts. The first part is it's a robotic platform. It's a 6-legged walking robot that adheres directly to the surface of the blade using vacuum. This enables us to get to all the key areas of a wind turbine, be it from the root right down to the tip. But the second part of what BladeBug is, it's the ability to have different tools. So essentially it's agnostic to whether it's to perform an inspection or perform a repair. But the way we do that is that we have a modular tool payload bay that we can take existing tools that the industry uses, mount them in a robot, and use them as if it's being used by a person on the blade, but actually that person is controlling the robot, be it at the base of the turbine or actually onshore, maybe a couple of 100 kilometres away. But we're getting the same results using the same equipment, but just being operated and provided by robots. Having built such a agile and dexterous robot for wind blades, there's also many other parallel sectors that we can diversify into, be it other forms of power, be it nuclear, construction, shipping, aviation. We're starting off in probably one of the most challenging environments possible, which is the offshore wind sector, meaning that all these other sectors are sort of ready and available for us to when we prove the sector and what we're doing. Oh, wrong way. So what we're doing currently, well, the year ahead for us is a real transition. We are transitioning from putting all the work we've done in the last 5 years in terms of research and development and taking our products to the commercial world. And we're doing that by, firstly, raising money. So we are currently raising 1.5 million to grow our team and perform the necessary growth that we need to get the robots out there. And by secondly, we're bringing our first commercial product to market, which is the ability to perform ultrasonic non-destructive testing scans on these wind turbine blades. So this is a really high value task of which there's very few people that are capable of doing it, and even fewer willing to do that on ropes. And so we're able to basically scan on a blade, gather data below the surface that you cannot see with a non-visual contact inspection such as a drone, and make a definitive answer about what is going on. And this is all about data. You can get more data to make more informed decisions about what you then do with that asset. And finally, we're growing, so we're recruiting. So we're looking for really skilled, enthusiastic robotic engineers who've got skill sets in coding, in hardware, using ROS, to carry on making our robot better and making it, succeed in the world out there. Anyway, that's me. That's BladeBug. I'm here. I'm joined by Axel, our CTO, and Stacey, our business development manager. If you'd like to find out more, our robot's over there. We'll be standing there. Come and have a chat. Yeah, that's it. Bye.
All right, thanks for that, Chris. And perhaps I've been sending too many emails to all the presenters about keeping it to 5 minutes, because this was 1 minute ahead of time. So we've got plenty of question time. Yeah. So one question here.
Yeah, I have
like 46 million investments, and how do you differentiate from that?
So just for the people who know, one of our competitors received a £30 million or $30 million investment back in December last year. We are wildly different in terms of our concept. So we've started offshore first. That's determined our size and form factor. So we're small, compact, lightweight. The robot's around 25, 30 kilos. It's the only robot out there that has the ability for aerial deployment and retrieval. Air owners, by comparison, their version, I'm going to call it a contraption, probably not the most diplomatic term to call it, but it's a device that uses ground-based winches to basically triangulate the position on a blade. Don't get me wrong, they're doing good stuff, but we're very different because we got that offshore focus first. It's really about that capturing that offshore market, and in particular, the challenges that's going to come with floating offshore wind and the challenges of these dynamic moving structures, and really removing the need for having to send personnel from vessels to that asset. So, yeah.
Also, any other questions, or are you starting to sense what's happening outside?
Yes, graveyard shift, so I understand.
Do you have another question down there, Pastor?
Hi. What's the advantage of having 6 legs instead of 4, for example?
Okay, so the question is, what's the advantage of having 6 legs instead of 4?
It's 2 more, isn't it? It's better. There's a couple of reasons. So 6 gives you the ability to walk with different walking gaits. So we walk primarily with, say, a tripod walking gait, so you have 3 points of contact, which is a very stable way of walking. It also gives you redundancy. So we can walk with 4 and 2 legs up. So if you have a failure of a leg, you've still got the ability to operate and perform tasks on that blade. 6 is just a very uniform number. If you look at insects often have 6 legs, insects. And yeah, we've been developing it around that sort of hexapod benefit. But yeah, it's really about the reliability and resilience to overcoming challenges if you have an issue with a leg, for example, with a problem. Yeah.
All right, awesome, guys. Thanks a lot for the presentation.
Pleasure.
I'll take the microphones. And with that, we're kind of finishing for the day. For the non-live stream audience, we got pizza and beers and soft drinks. You at home or at office. Obviously, yeah, help yourself to whatever you have available. Yeah. With that, thanks for everyone for coming, and have a really great networking event now. We're closing at 9, so if you can make your way out after 9, that'd be great. Yeah. Thanks a lot, guys. Cheers.